guys, welcome back. So I hope you had a fabulous new year and a great Christmas. Glad to be back. I hope everybody is recharged and refreshed and ready to go. We got 2 weeks to finish up this semester. So let's try to finish it strong and do what we can and get our assignments turned in. And we'll test at the end of this 2 weeks, and hopefully you guys have retained some information and we can move on into the third 9 weeks and start a new semester. So what I wanted to kind of do is, since it's been a while since we've talked about ionic compounds, I'm going to start today with the transition metals. We ended with that, but it was very brief, and I felt like maybe you guys, some of you didn't understand how to exactly do that. So let's start off with reviewing transition metals, and then we're going to move into naming ionic compounds with polyatomic ions, and I'll explain that in a little more detail. So let's review what a transition metal. So if you're looking at the periodic table, it's that section in the middle of the periodic table, the D sublevel and the F sublevel. Those elements have what they call transition metal, or are called transition metals, because they can change their oxidation state. Remember, the oxidation state is the number of electrons lost or gained from a particular atom. Now, we're talking about metals, so we're going to be talking about how many electrons are lost. With transition metals, they can alter the number of electrons that they give away. So therefore, their charge, their positive charge, can change from a 1 to a +2 to a +3 to a +4, some even 5 or 6. So the way that we represent that is by using what we call a Roman numeral. Okay, so transition metals with two different ions use a Roman numeral after the name of the metal to indicate what the ionic charge is. So if we have something like FeCl2, okay, if you look at the subscript on the non-metal, the second element listed in the compound, that is going to tell you the charge on the metal ion. So if I were to name this, I'm going to name this Fe is iron, Cl is chloride, and then I'm going to look at this 2 on the chloride, the subscript, and that's going to give me the Roman numeral with the iron. So this would be iron 2 chloride. Now if you look at the next one, still iron and still chloride, but now that 3 tells me that instead of a Roman numeral 2, I would have a Roman numeral 3. So this one is iron 3 chloride. What if we had copper? Well, you see there's a 2 on this copper, meaning the charges didn't cancel out because there's a 1 on the sulfur. So this would be copper and sulfide. But remember, we're always looking at the second element listed. So this is not going to go with the copper. The 1 is going to go with the copper. So this would be copper 1 sulfide. Now what if we had CuCl2? Okay, so that's still going to be copper, but now it's copper 2 chloride. And then here we have tin and chlorine with a 2 here, so that's going to be tin 2 chloride. And last, we have Pb, which is lead, and then Br, which is bromide. That 4 on the Br is going to tell you the charge, the Roman numeral, on the metal ion. So this would be lead 4 bromide. Okay? So that's how you name using the Roman numeral system. Okay? You'll notice that most of your transition metals are your most colorful chemicals, and they use them in paints as well. Okay? The pigments in paints, we talked a little about that. Many transition metal compounds are colored and can be used as pigments when painting. Okay? Now, let me skip on through here. Okay, that's the stock system. This is the way we name them. This used to be the older method. For example, copper 1 was cuprous, copper 2 was cupric. So the lower number gets the OUS, the higher number gets the ic ending. Okay? All right. So that's how you'll name, okay? You determine the charge of the cation from the anion. You name the cation followed by the element name and add the Roman numeral, okay? Now, let's try to write formulas. So same thing. If I tell you that it's iron 3, that means it's Fe plus 3. Chloride, you would just look up on your table, and that would be -1. Now remember, back to what we were talking about before. You have to balance out the charges, right? So I need 3 negatives to cancel out a 3 positive. So I would need 3 Cl's, okay, in order to get me a -3 charge, so that the sum of your charges equals 0. So what that means is I need, for every 1 Fe, I'm going to need 3 chlorines. So when I write that formula out, it's going to be FeCl3, okay? Now, what if we had copper 1 and nitride? So copper 1, meaning it's Cu plus 1, nitride is an N minus 3. So you have a plus 1 and a minus 3. They don't cancel, so you crisscross them, and when you write it, it's going to be CuN3, okay? And then lead 4 oxide, plus 4, you need 2 oxygens in order for that to cancel out. So it's PbO2, okay? All right, so if we were to name these particular elements, okay, V2S3, remember you're looking at the subscript on the second element. So that would be vanadium and sulfide, but then the 3 on the sulfide makes it, whoops, I don't know why that didn't do that. So this would be vanadium 3 sulfide. This would be titanium 2 oxide, iron 3 phosphide, and copper 1 selenide, okay? So that was just a learning check for you. All right, so let's move on, okay? Now, what if we had copper 1 sulfide here, okay? So sulfur has a -2, copper with the Roman numeral of a 1 has a +1. A +1 and a -2, if they don't cancel, remember the crisscross method. You just drop your charges and cross your numbers. So this would be written as Cu2S. Now you have iron 3 phosphide. Iron 3 means it's a +3. Phosphide has a -3. A +3 and a -3 cancel, so you would have FeP, no subscripts. Next one is manganese 2 fluoride. Manganese 2 means it's a +2. Fluoride has a -1, so a +2 and a -1 don't cancel, so you drop your charges and crisscross. So it's going to be MnF2. Platinum 4 bromide. Okay, so platinum 4 means it's a +4. Bromide means it's a -1. A +4 and a -1, they're not the same number, so you drop your charge and crisscross. So platinum is Pt, so it'd be PtBr4 as a subscript. And then the last one would be chromium 6 oxide. So chromium would be a +6, oxide would be a -2. They don't cancel, so you crisscross. +6, -2, cross them, so it would be Cr2O6. But remember, least common multiple, you would have to simplify that into CrO3 is what the final would be, okay? All right, so now we're going to move into the new stuff, okay? So what I just went over, those writing and naming using transition metals, was a review of the last few things we did right before break, okay? So now we're going to get into compounds naming with common polyatomic ions. I'm going to take a little break and check my video.